Reaction of metals with water. Let us discuss an activity. Collect the samples of few metals. Put small pieces of the samples separately in beakers half filled with cold water. Which metals reacted with cold water? Arrange them in the increasing order of their reactivity with cold water. Did any metal produce fire on water? Does any metal start floating after some time? Put the metals that did not react with cold water in beakers half filled with hot water. For the metals that did not react with hot water, arrange the apparatus and observe their reaction with steam. Which metals did not react even with steam? Arrange the metals in the decreasing order of reactivity with water. Sodium is dropped into cold water. Sodium will react vigorously, forming sodium hydroxide and hydrogen. The heat evolved is so large that hydrogen will catch fire. How can you confirm the presence of hydrogen? By bringing a burning candle near hydrogen gas. You know that if a burning candle is brought near hydrogen gas, it will burn with a pop sound. How can we confirm the formation of sodium hydroxide? If few drops of phenolphthalein is added to the beaker, we will be able to see that the solution turns pink. Pink color indicates the formation of a base. Here it is sodium hydroxide. Metals react with water to produce metal oxide and hydrogen gas. But certain metal oxides that are soluble in water dissolve in water to form metal hydroxide. So we can write the equation as metal plus water gives metal oxide plus hydrogen. Metal oxide plus water gives metal hydroxide. Let us see how the following metals zinc, aluminium, copper, iron, magnesium, mercury, calcium and potassium react with water. Here we should consider water taken as cold water, hot water and steam. If a metal can react with cold water, it shows that the metal is highly reactive. If a metal reacts with hot water, it shows that the metal is less reactive compared to the metal which reacts with cold water. And if a metal reacts with steam, it shows that the metal is less reactive compared to the metals which react with cold and hot water. Thus, from the table, it is clear that reactivity differs from one metal to another. Now, consider the case of sodium and potassium. Since sodium and potassium reacts with cold water, these two metals can be taken as highly reactive. What are the products formed in the case of sodium? The products formed are sodium hydroxide and hydrogen. And in the case of potassium, when it reacts with water, the products formed are potassium hydroxide and hydrogen. Consider the metals like sodium, potassium and calcium. Since potassium, sodium and calcium reacts with cold water, these metals can be taken as highly reactive. Which are the products formed in the case of sodium? When it reacts with water, the products formed are sodium hydroxide and hydrogen. And in the case of potassium, the products formed are potassium hydroxide and hydrogen. And when calcium reacts with water, the products formed are calcium hydroxide and hydrogen. It is also found that when sodium and potassium reacts with water, energy released is so large that hydrogen evolved catches fire. Now let us see how to write the balanced chemical equations. In the case of sodium, 2Na plus 2H2O gives 2NaOH plus H2 plus heat. And in the case of potassium, 2K plus 2H2O gives 2KOH plus H2 plus heat. And in the case of calcium, Ca plus 2H2O gives CaOH twice plus H2. Calcium also reacts with cold water, but the reaction is less vigorous compared to sodium and potassium. Now let us consider magnesium. Magnesium reacts with hot water. It does not react with cold water, which shows that magnesium is less reactive compared to sodium, potassium and calcium. What are the products formed when magnesium reacts with water? The products formed are magnesium hydroxide and hydrogen. Now, how can we write the balanced chemical equation? Mg plus 2H2O gives MgOH twice plus hydrogen. Now, another important observation with respect to calcium and magnesium is that the metal starts floating over water. Why is it so? It is because hydrogen gas evolved being lighter sticks to the surface of the metal, which makes the metal float over water.